Hi guys, welcome back to STEM Storytime. My name is Taylor, and today we are going to be reading a book called Crayola, Science of Color. I know how to say that word. Then we're also going to be talking about a little scientific phenomenon called capillary action. So let's get into it. Color all around. We see colors all around us. Color is everywhere. What is color? We see color because of light. Light lets us see all the colors of the rainbow. Sunlight shines through raindrops to make a rainbow. Green, blue, yellow, and red. Everything we see has a color. Light bounces off materials so we can see them. Green light bounces off a green shirt. Yellow light bounces off a yellow shirt. Eyes have tiny parts called cones. Cones help us see colors. Light touches the cones, and the cones tell our brains what colors we see. Colors work together. Some colors mix to make other colors. Some colors help other colors stand out. Yellow, red, and blue are called primary colors. Primary colors can't be made from other colors. Orange, green, and purple are secondary colors. They are made by mixing two primary colors. So, red and yellow makes orange. Blue and yellow makes green. Red and blue makes purple. A color wheel shows us how colors are related. Complementary colors are opposite on the color wheel. Purple and yellow are complementary colors. They are bold and easy to see. So notice yellow and purple are opposite each other on the color wheel. So that means red and green, these are complementary colors, and then blue and orange are also complementary colors. Red, orange, and yellow are warm colors. They remind us of the sun. Blue, green, and purple are cool colors. They remind us of water and the sky. We learn more about colors all the time. Scientists made a new bright blue pigment by accident. They called it Yilman blue for the chemicals it's made of. I don't know how to pronounce that. If you want to look it up and figure that out for yourself, that's a great thing to research. I'm going to call it Yilman blue. Colors look different with different colors around them. Which red box looks the brightest? What do you think? Sometimes colors stand out. Sometimes colors blend in. Can you find the insect hidden in the fall leaves? That moth is blending in really well. Colors can make us calm. They can also give us energy. What color do you like best? There are so many pretty colors. The world is filled with so many. That's very, very basically explaining the idea of colors, the science behind colors. So we learned about colors and the color wheel, that there are complementary colors. And today I want to talk a little bit more about the three primary colors. So I have with me some food coloring, just some gel food colorings. I've got a blue, red, and a yellow. It says yellow on it. That also came with a green, but for today's experiment, I'm just going to work with the 3 primary colors. So what I did, I wanted to try to mix my own colors together. So let me show you. All right, I can do this. Here they come. Try to be gentle with this. Don't want to knock over all of my jars. So here's a fun experiment you can try at home. I have 5 jars right here. And in these jars, I have different colors. So you'll notice I have red, orange, yellow, green, and blue. Now the orange and green, I didn't have a color to make that. I made it myself using just these 3 food colorings. So you can easily do it at home. All you need is clear jars, some water, some paper towels, and some food coloring. So you take a jar with water and you pour in as much as you want, really. I ended up using a fair bit to help it get really nice and saturated. It filled up really nice. Now, this did take a bit of time for the colors to mix, but as you can see, I took a paper towel like this one, and you dip it in one end and then dip it in the other. So these 2 jars were clear. They didn't have any color in them. But if you remember from our color mixing page, I took the red jar and the yellow jar, and then I mixed them together with paper towels. I dipped the paper towel in one end, put it in the other, and so that made together, the 2 colors mixed together and made orange. I did the same with yellow and blue and made green. So I'm going to try to see if I can get purple this time. Not sure if it'll work, but we'll see. This takes a little bit of time as well. I had to stir these a lot in order to get them to look nice. I'm going to take this clear jar. We're going to try and work this in here. Okay. We've got red and blue. So as we remember from the book, red and blue makes purple. I also want to explain another quick piece of information. I told you we were going to talk about capillary action. Capillary action is what happens when water, or any liquid really, but water is the one we're going to use. Water molecules move up. They walk up a piece of paper. In this case, I'll show you here. When I dip my paper towel into this jar of blue water, you'll see it's moving up. See how the color, it's a little hard to see from this side, but you dip it in and the water keeps moving up all on its own. That is called capillary action. Capillary action happens because of 3 forces: cohesion, adhesion, and surface tension. So those are fancy words that basically mean in cohesion, water molecules, which everything is made up of molecules, the water molecules, they like to stick together. They like to be really close to one another. So that's called cohesion. They also like to stick to a solid surface, like this paper towel. That's called adhesion. So what you're seeing right here, water, the water molecules are adhering, they've adhered to our solid object, our paper towel. Lastly, there's a thing called surface tension. So have you ever gone swimming in a pool and you've done a belly flop and it hurts real bad? That is because there is surface tension on the water. That just means that the molecules are more closely bound at the top, the surface of the water. So there's tension there. So that's just a very basic explanation of it. But what that means is when you dip the water or the paper towel in the water, the molecules, because they have cohesion, they stick to each other, they like to adhere to the paper towel, and then because of surface tension, they basically walk up the paper towel. You can sort of see it slowly happen in there. They're making their way up. So I'm just going to speed it up a little bit because try to get this going. So you see, I've dipped paper towel in the blue jar, in the red jar. And now we're going to try to get these to turn purple. Now, at first, it doesn't look like much is happening, but that's how my orange and my green ones were earlier. It takes a little bit of time, so this is one you have to be patient with. If you set it for a while and you come back, maybe 30 minutes or so, you should start to see something, but if you stir it, that helps it move along. I'm going to speed things up for the sake of the video though, and I'm going to just help it along a little bit. I'm going to squeeze some of the red. You can see it leaving behind a cloud of red liquid. Okay, so now there's a little bit more red in our jar. Now we need to do the same with the blue. Squeeze the blue in there. We're going to see when we stir it up now. It should start to turn a little purple. I think we need a little bit more. So here we go. More red. More blue. There we go. It's starting to look purple. So, now you can notice it's not a very bright purple yet. It's still kind of very diluted. But the more we keep adding our red coloring in, and the more we add our blue, it's making it darker and darker, making the colors more vibrant. And if I had time, I would let this just sit and diffuse all on its own. But I'd like you guys to be able to see some purple showing up in here. Now, what could be fun at home to try is doing different amounts of different colors and see what colors you can make. So my purple is kind of showing up, not nearly as great as my green over here, or my orange on the other side. Oh, rotate. Yeah, my orange turned out really well, I think. Eventually, the purple will be even more bright, and I'll have a nice, pretty rainbow of colors. They're beautiful. I love them. This was a super fun experiment, and honestly, it's super, super easy. Glass jars or clear jars. It could be plastic if you have little plastic tubs. Food coloring and water and paper towels. I recommend warmer water. It helps to break up the food coloring a little bit. But yeah, so this was a fun experiment. We learned about colors and capillary action. And what can you make at home? I think you can make all kinds of fun colors. All right, see you next time. Bye.